If James Bond had the license to kill anyone, James Webb has got high sensitivity and resolution to track down any criminal particles in space. Why? Don't you think the unprecedented meteoroid attack on Earth is a crime? Welcome to Tech Beyond Gravity. A telescope can collect about 500,000 times as much light as our eye. To know more about deep space, we need an extensive device that can tell us stories through pictures. That is why NASA launched the Hubble telescope in 1990 into low Earth orbit. But last year, James Webb Telescope, referred to as NASA's second child, was launched and found to be orbiting around the Sun. It is situated 1.5 million kilometres away from the Earth at a position called the second Lagrange point, or 1.2. We know the tale of Galileo when he claimed that the Earth was round and ships falling over the horizon was absurd. But what if it was in space? Has something terrifying been discovered at the edge of the universe? Now, to actually detect what is going on at the edge of the universe, a powerful telescope like James Webb has to be equipped well. It is said that the telescope is 100 times more efficient than the Hubble telescope and is programmed to capture images 10 to 100 times fainter than Hubble. The images produced by both the telescopes differ due to the difference in wavelengths. Webb is more powerful as it has the ability to procure images using infrared lights, whereas Hubble telescope observes light at optical and ultraviolet wavelengths. Due to this, it can even sense the heat of a bumblebee at the distance of the Moon. Webb is located far away and thus is colder, which is optimum for the smooth functioning of its pieces of machinery. It is with the help of a 5-layer sun shield that protected the side of the telescope experiencing around 260 degrees Fahrenheit. The shield is as huge as the size of a tennis court, and it has to be folded to fit into the launch vehicle. A breakthrough achievement of the James Webb Telescope can be attributed to finding the first galaxies that formed in the early universe and detecting the stars as part of the planetary systems. This was something that could not even be conceived with the help of the Hubble telescope after the Big Bang. Just imagine 13.5 billion years, and the JWST can capture all the light waves hovering in the cosmos for that much time. The telescope also has a 6.5-meter primary mirror that consists of 18 hexagonal plates. The segments are covered in a gold coating so thin that a single strand of human hair is 1,000 times thicker. An issue faced with the James Webb Telescope is that the operators or crew members are helpless when it comes to repairing it at the time of launch or operation. This was not the case with the Hubble telescope, as 5 space shuttle crews have made service calls to perform the necessary upgrades. But this was easier as the Hubble telescope was just 340 miles away, unlike JWST, which is nearly 1,000,000 miles away. The JWST cannot be refueled. However, a scientist made his research and said that the telescope will function for 20 years without refueling. Astronomers claim that the JWST may find evidence related to finding artificial light on an exoplanet named Proxima b, Earth's closest planet, which is located 4.2 light-years away from Earth. Exoplanets, or the planets outside the solar system, were difficult to detect until the advent of the JWST. The $10 billion JWST is making history even before it was launched, thanks to the engineering of the mirror, which has become an inspiration for eye surgeons. Humans have been inquisitive to know more about what lies beyond the naked eye. This involves answering questions as to what surprise the edge of the universe has in stock for us. For a common man, this edge might seem to be stupid, as there cannot be an end as there isn't a beginning. So before we discuss this, let's delve into the dimensions of space. Scientists have come to a conclusion that our universe spans around 28.5 gigaparsecs in width. Now, a person who is not into physics or astronomy can find this measurement confusing. Parsecs represent the distance at which the mean radius of the Earth's orbit subtends an angle of 1 second of an arc. In simple words, 1 parsec is equivalent to 3.26 light-years, or the distance light travels in 1 year, which is 9,460,000,000,000 kilometers. So 28 gigaparsecs would be equivalent to 93 billion light-years. One question that triggers confusion is, will the universe expand? Since the expansion is against the law of gravity, the universe and all the matter that is within will stop expanding and collapse and form a mass. According to Hubble's law, the objects observed in deep space are found to be redshifted. In other words, the galaxies are moving away from Earth at speeds that correspond to their distance. The farther they are, the faster they move. As a converse, if the universe was static and unchanging, there would be no correlation between distance and velocity. In 1929, Edwin Hubble made a discovery that the galaxies appeared to be moving away from us, a phenomenon associated with the expansion of the universe. Also, each galaxy tends to separate from one another and become an exclusive cloud of mass. This was known to be the redshift of a galaxy spectrum. An amazing fact is that this expansion is ongoing and accelerating. It is not just the matter that is moving from one another, but the vast volume of space itself is amplifying. This could be a reason why the edge of the universe is not the constant 13 billion light-years from Earth. It's estimated much beyond that. Is it possible to observe each and every bit of this universe, including the object located far away? The observable universe, or the part of Earth that is visible, is almost flat and uniform. The uniformity is contributed by the positioning of the galaxies that are more or less evenly spaced. Since the speed of light is finite, the distance required by light to reach a particular distance is also fixed. Therefore, the light rays from the farthest location have not yet reached the Earth's surface. These are located beyond the sphere of observation, or the observable universe. The current cosmic event horizon is 16 billion light-years away from Earth. Beyond this, the expansion of space is faster than the speed of light, so this could be a reason why the light rays from this point fail to reach Earth. So it might be a near impossible thing to observe any phenomenon taking place beyond this horizon, if it were not performed by the highly sophisticated JWST. The last scattering surface, or the cosmic photosphere, located 46 billion light-years away from Earth, is what we observe in the night sky, irrespective of the direction we look at. It is the most distant thing we are able to see with our naked eye, with all other observable elements situated in front of it. The surface of last scattering is like a uniform sphere of fog, from which the first ever photons of cosmic microwave background radiation came after recombination and photon decoupling. The surface of last scattering constantly moves away from us, both due to time passing and due to the Hubble expansion. The increase is not overtly significant to the universe as a whole. Now, as to the most awaited question. Does this mark the edge of the universe? The edge of the universe is an imaginary boundary that divides the space between the ones that is visible to the Earthlings and the one that is not. Everything that comes within the boundary is called the observable universe, and beyond that lies the opaque universe. The edge of the universe also holds the particle horizon, or the maximum distance one can see into the past. Now, to confirm whether the universe has an edge or not, a question should be answered: whether the universe is infinite or not. As per many hypotheses, there is a debate going on and has become a bone of contention among many scientists. The universe did not start as a finite energy at one point. The Big Bang responsible for the formation of the universe did not confine to one place. It occurred everywhere in the universe simultaneously. The universe may be infinite, but we can only see a finite side of it due to the finite speed of light. According to Einstein, the universe goes on forever and has no edge, or one that curves back on itself like a high-dimensional version of the surface of a ball, and so also has no edge. Einstein's theory suggested that the universe cannot be static or changing. It is in constant motion, either expanding or contracting. So do you think our universe is finite or non-finite? Does it have an edge or not? Well, it is up to you to probe deep into these scientific questions and comment below about your observations. Also, make sure to like this video and subscribe to our channel for more updates. Turn on the notification bar so that you get the recent posts of our latest videos of our channel. Until we meet next time with another exciting video, goodbye.